Okay, in this video we're going to talk about the pitfalls of internal rate of return. And in the previous video we talked about the relationship between NPR and the internal rate of return using this graph. So we learned that there is a inverse relationship between the discount rate, which goes this way, and the NPV, and as discount rate increase, NPV goes down like this in a monotonic fashion, and the internal rate of return is the value of R that makes the net present value equal to 0. So usually what happens is that when the market discount rate is less than the internal rate of return, like 5%, then net present value of the project is also positive. So when there is a project that has a positive net present value, then the internal rate of return of the project is also greater than the discount rate. So usually the NPV and internal rate of return agrees. The problem is that that's not always true. So we are going to go over two pitfalls of the internal rate of return. So the first thing that we are going to cover is the case of the multiple rate of return. So let's go over this using an example. This is a problem, again, your textbook. There is a mining company called King Coal Corp. It is considering a strip mine project, and it requires initial investment, and after the initial investment it will generate cash flow of 125 and 175 over the next 4 years. And after the project is over, there is a cleanup cost of $400 million in year 5. So what makes this project unique is that now we have two different cash outflows, and the first cash outflow is usually happens in the first year, and in this case there is a second cash outflow that happens at the end of the project. The problem with this one is that because of the structure of the cash inflow and the outflow, the relationship between the net present value and the discount rate is not monotonic anymore. So when we show the relationship between the two using a graph, this is the relationship between the discount rate and the net present value. So this is the discount rate again, and this is the net present value. And in this case, because there are two separate cash outflows in year 0 and year 5, when the discount rate is really low, the net present value actually increases. And after a certain point, net present value starts to decrease. So there is a quadratic relationship between the discount rate and the net present value. And because the definition of the internal rate of return is the discount rate that makes the net present value equal to 0, now we have two separate values of internal rate of return that makes the net present value equal to 0, right? Which is a problem. But a bigger problem is that neither of them are actually correct. So this is the Excel file of the King Coal project, and I already calculated the internal rate of return here. And you can see that the Excel tells you that the internal rate of return of this project is 3.09%. A problem with this one is that if the internal rate of return of this project is indeed 3.09%, and if the discount rate of the capital, if the opportunity cost of the capital is 5%, then the company should not initiate this project because the rate of return of this project is lower than the opportunity cost of the capital, right? Now, the problem is when we actually calculate the net present value of this project using the 5% return, as the discount rate, right? So as I told you before, in the NPV function, highlight all the future cash flows and then add back the initial cash outflow, right? Then you will see that the net present value is actually positive, right? So there is a contradiction between the internal rate of return and the net present value. So in this case, what do? Right? So which one is correct? So whenever there is a disagreement between NPV and the internal rate of return, you should go with the net present value. So if the market discount rate is 5%, and if all the projected cash inflow and outflow are correct, then this is a good project. And because the net present value is positive, and you should go with the net present value. Now, how do we fix the problem of the internal rate of return, right? You may ask, hey, if NPV is correct, then why do I need to calculate the internal rate of return? The answer to that question is, how do you answer the question on what is the rate of return of that investment, right? So we know that the rate of return of this investment is not 3.09%, right? We know that it's not accurate. Then what is the better measure of the rate of return of this specific project? To answer this question, there are two different ways. One is a more educational, right? So one of the reasons why we have a problem with the internal rate of return is that there are two separate cash outflows, right? And because of that, the relationship between NPV and IRR, NPV and the discount rate is not monotonic. So one solution to this problem is to calculate the present value of the cash outflows in year 5 and add that back to the initial cash outflows. So this is the initial cash outflow, right? And then we calculate the present value of this. Right? To calculate the total cash outflow in year 0, right? Then all the other cash inflows are the same as the original project, right? Then when we actually calculate the internal rate of return of this project, you will see that the internal rate of return of this project is actually 5.32%, right? So you can see that this discount rate, this internal rate of return, is also greater than the discount rate, right? So this is a project that produced 5.32% return that is greater than the opportunity cost of the capital. So according to the internal rate of return, this is a good project, right? And how about the NPV? Right? So in case of NPV, so I will calculate the NPV using C1. And you can see that these two projects actually have exactly the same net present value, right? It makes perfect sense. So now when we make this adjustment, you can see that now the internal rate of return and the net present value are in agreement. Okay. So that's the kind of adjustment that you may have to make, right? Another solution to this problem is to use the modified internal rate of return. Okay. One of the problems of the internal rate of return is that, there is an implicit assumption that when a company gets a positive cash inflow like this one, right? Internal rate of return assumes that all these positive cash inflows will be reinvested and earn the same return as the internal rate of return, right? That's not always true, and it creates a problem in many cases, including this one. So we can actually solve this problem by separating the cost of financing and the reinvestment rate. And that's what MIRR is for. So in case of modified internal rate of return, we highlight all this, right? Then modified internal rate of return will ask for finance rate and the reinvestment rate. So in this case, we are saying that both the finance rate and the reinvestment rate is the discount rate, not the internal rate of return. Then you will see that this is very similar to the rate that we just calculated. Okay, so that's where the concept of modified internal rate of return comes in. And if you want to learn more about the modified internal rate of return, please take a look at the handout on the modified internal rate of return that is available on Moodle. Okay, now let's go back to the PowerPoint and talk about the second case of the internal rate of return pitfall. Okay, so that's the case when there are 2 or 3 mutually exclusive projects, right? So you have 2 competing ideas on how to use a existing resource, right? So if you have a building that is empty now, and you have 2 different ideas on how to use that building. And once one of the idea is initiated, and obviously the other cannot be realized. So that's the case. That's an example of mutually exclusive project. So the question is, when you have 2 mutually exclusive projects, and then you have to make a decision on which one is better than the other. When you use the net present value to decide one is better than the other, that's perfectly fine. But when you use the internal rate of return, sometimes bad things happen. So we'll go over that. So this is the example that we actually covered before, right? Do you remember the office building case? So the company will spend $350,000 to buy a building and get $16,000 rent for 3 years and sell it at the price of $450, right? So we talked about that case. Now, let's say there is an alternative project of the same building, which is buy the building at the price of $350, but instead of getting the rent and so on, you just sell it at the price of $400. Okay, so which one do you think is better when these 2 are mutually exclusive, right? If they are not mutually exclusive, then you can simply calculate the net and NPV of this project, and as long as the NPVs are positive, you can initiate both. But in this case, because they are mutually exclusive, having a positive NPV is not a solution to this problem. Okay. So let's go over the Excel file. Okay. So here I calculated the internal rate of return of that long project, the original project, right? So this is a long project because duration of the project is 3 years, right? And the revised plan, the short project, is much shorter, right? Because your holding period is just 1 year. Okay. We already calculated the internal rate of return of this project, and the textbook says that the discount rate is 7%. So the net present value when the discount rate is 7% is $59.32. So this is a good project, right? Because the internal rate of return is greater than the discount rate, NPV is positive, right? But that doesn't mean that you have to initiate this project, because there is a chance that the alternative project may have a better return, right? So internal rate of return of this project, right, is actually greater, right? But how about the net present value? So now you can see that, again, there is a disagreement between internal rate of return and the net present value. So according to the internal rate of return, short project is a better one. According to the net present value, long project is a better one. So what do we do? Again, whenever there is a disagreement between NPV and internal rate of return, you go with the NPV, right? So the short answer to this question is, hey, choose the long project, right? Now, you may ask why they do not agree, right? Why there is a discrepancy between the internal rate of return and the net present value. To understand the reason why, we actually have to go back to the PowerPoint. Okay. So this is the chart that shows the relationship between the discount rate and the NPV of each project, right? So this is the connection between discount rate and the NPV of a long project. NPV of the short project. And this is the long project. Okay. So when you look at the internal rate of return, which is the discount rate that makes the net present value equal to 0, this is the internal rate of return of the short project. And this is the internal rate of return of the long project, right? So according to the internal rate of return, short project is better than long project, right? But according to the net present value, so here the discount rate is supposed to be the 7%. This is the net present value of the short project, and this is the net present value of the long project, and net present value of the long project is higher, right? So why does this thing happen? The reason is because the duration, do you guys remember this concept? Duration and the interest rate risk. The duration of the long project is a longer. So long project, the net present value of the long project, it's much more sensitive to the changes in the discount rate. So that's the reason why its graph is steeper, right? In case of the short project, it's just like a short-term bond, right? It's not as sensitive to the changes in the discount rate. So its profile is much more flat. Okay. So when the discount rate is 12.26%, their net present value is exactly the same. But if the discount rate is less than 12.26%, then long project has higher NPV. If the discount rate is higher than 12.26%, then short project has a higher NPV. So what's the take-home message here? The take-home message is when you compare two projects, right? When you compare two projects, they are different in any way, right? In this case, there is a difference in the duration of the mutually exclusive project. And when you make a decision on which one is better, you do not want to use the internal rate of return. In that case, you want to use the net present value. Okay? And also it'll be really nice if you understand why the NPV function of long project is steeper and NPV graph of short project is more flat. And why that difference leads to this kind of conflicting recommendations by internal rate of return and the net present value. Okay, so hope this helped you understand the relationship between NPV and internal rate of return better, and help you understand the pitfalls of the internal rate of return. Okay, then now we'll move on to the part number 3.